Hey everyone, it's really, really good to be back in Verona. I was here last year. It's really good to come back and have this many people come see me, so that's cool. I'm Irina, I'm an engineer at MongoDB. I am here again for the second time, and I'm gonna talk to you about HTTP2. And I have two friends to help me out in this kind of difficult topic, so their names are Beep and Boop. And they're going to help me explain a few concepts. So yeah, HTTP2. HTTP2 is a topic. I kind of had this fancy name, HTTP2, one frame at a time, because I thought it was really funny, but I think I was the only person that thought it was really funny. So I changed it to just require HTTP2. So we're going to talk about it in a node concept kind of thing. So why should we talk about this? A few people have kind of spoken about what is HTTP2 and how important it is, and a few people say about it, it's a major protocol shift with the potential to accelerate the web. It's a faster and simpler and more robust protocol that will make our applications faster. These are the folks who write stuff at Google. And it makes it a lot more efficient to parse and send more compact stuff over the wire. And it's essentially meant to be a lot more error prone. So what is HTTP2? So today we'll talk about a few things. Kind of compare them a little bit quickly as to what is the difference between the two. Maybe some of you have heard about it, maybe not. We'll talk about kind of more about the specky stuff. How does HTTP2 kind of handle certain portions of the application code? How does it handle stuff over the wire? Things like that. We'll code a little bit, mainly because I usually show these examples, but we have so much time, so I thought we would code together. And we're going to talk about why is it so much more performant. And we'll also talk about server push, and that's kind of the fun things about HTTP2. So we'll start with kind of like, what is the difference between HTTP1 and HTTP2? Again, meant to be a lot more performant, helped with perceived latency that users experience, and supposed to help with network and server usage. That is HTTP2. But first, kind of, let's look back in the year 1999. That's when the currently used protocol was put together in 1999, so that's like 20 years ago. I don't remember what 1999 feels like in computer age, because I was like 8 years old. So people talk about Neopets. I had internet at 1998, so I didn't have Neopets because my internet was too slow to handle Neopets. I don't know Neopets. But basically what I'm trying to tell you is that I looked into stats over HTTP archive. The latest thing they have is from 2010, but the request usage from 2010 to current has increased. So we're sending a lot more traffic over the internet, and it's kind of not news. I think we all know about it. But so what I'm trying to tell you is that the protocol we're currently using is 20 years old, and technology is developing, and we kind of have to look into something else. So how does HTTP1 works? You have a single TCP connection, and you have a single request getting handled in a single TCP connection. What happens is that you kind of have what some people call head-of-line blocking. So when certain packets come through a request, you have a certain packet, first packet in queue that's getting processed, but all the other ones are stuck behind it. So you're kind of stuck in this queue trying to get through your requests and your packets. But in 2015, we came to this new protocol, HTTP2, and what's that meant to do is kind of help us with being able to handle more requests and being more efficient about it. So what happens with HTTP2 is you have a single TCP connection, but instead you have several streams and several requests that can go through a TCP connection. So instead of having the one-to-one ratio, like we've seen before, you kind of have one-to-many. And that's what's awesome about it. And we're kind of, throughout this talk, we're going to deep dive into some of the concepts that surround this kind of graphic. So I want to focus specifically on a couple of little wins, as I'll call them, throughout this talk. And they are, we'll talk about stream prioritization, we'll talk about server push, and we'll talk about what's up with the header compression and how that makes this protocol a little bit more efficient. So to start off, let's kind of talk about the connection and how the connection happens. So again, you have a single TCP connection. You have multiple streams that get through the TCP connection. And a single stream is made up of several frames that get through. And frames carry things like data. They carry things like headers and carry settings and information that one wants to pass over to the other. And instead of all being in a single request, is divided up into frames. So when you kind of try to make a request, what you don't know as a client that's trying to connect to the server, whether it's like your browser or like a different server, is you don't know if you're going to have to, you're going to be able to accept HTTP2. So what you start off with is an upgrade header. An upgrade header kind of lets you know that, hey, eventually, like I would like to upgrade, but I'm not sure if you're going to be able to. So I'm going to set this up. So then you go through the process of negotiations. So you start off with wanting to connect, kind of ring up the server and ask that you would like to connect, and eventually do an upgrade. Then the server sends back an upgrade saying it's a 101 response that is OK to connect and OK to upgrade. And then kind of go through this process of agreeing on a lot of things. It's a very mature, a very kind of very civil relationship here. The other one will also agree that upgrade has happened, and then you acknowledge that the other person acknowledged the upgrade. And you send over settings frames as to what you would like from these connections. Things like maximum amount of flow control you would like to allow, or things like the headers you would like to take and stuff like that. So all of those comes through setting frames. So at this point, we kind of talked a little bit about how a server makes a connection, but I would like to actually sit down and code some things. So we'll start with building a little server. Cool. Okay. I'm going to write this one. Sorry, I should have actually HTTP2 server example.js. So I'm going to use this package called Tls Keygen that allows me to develop locally. I'm going to borrow that code because it's a little bit of boilerplate that you have to do. So I'll just copy certain things over. I like the soundtrack too. Can we keep it? All right. So essentially, what we want to do is we want to be able to send something back and create a secure server right away, which is why I'm setting up, and which is why I'm using Tls Keygen to be able to get the cert and the key to pass into the secure server. So we'll start off with http2.create secure server, and what we're going to do is we're going to pass in the key and the cert files, or the certs that we've created. You can't really see this, so I'm going to close this. Better? Yep. Can everybody see this in the back, or is the font too small? Okay, great. We're going to handle the error if one comes up. And And once a request comes in, actually we won't bother with the request at the moment, we'll deal with the stream. So we have a stream event that we can then figure out what data is coming through, and we can then send some stuff over. So you get a stream, and then you get headers, and that's it. So I also want to look at what the headers are like. So what I'll do is I'll console log those so we can see them. And then when stream comes in, we just want to be able to respond with something. And stream is going to respond with a few things. The first one is just a status code. So with HTTP2, you kind of have a little bit of fancier header names. So they're colon status instead of the regular non-colon things. So you kind of know when something is HTTP2 like that. It's like an easy way to tell. So we're going to do status, and we're just going to send over a message. That's just going to be sorry, that's all the way at the bottom, so I'm just going to do this. So that's what we're going to respond with, and then we're just going to end the stream. So stream.end, and then I'm just maybe we'll send over some body tag. So it looks a little bit familiar, but a little bit different than what you would normally see. And the one thing that is very familiar is we just have to be able to listen on a certain port. All right. So this one is going to create a secure server, so we're just going to have to use HTTPS. And I'm going to just curl it. All right. So we're going to start the server. So node HTTP2 example. No, server example. Nice. Oof. Oh, you know what I forgot? I know what I forgot. All right. No.
You are not calling the main function.
Right. Thank you. All right, cool. So we're just going to need to save the certs and the keys into the keychain. And I'm just going to do a curl and ignore experimental warnings. Localhost, and we're doing it on 8001. Localhost 8001. Cool. So we get a protocol of HTTP2. It's 200 response, we get all the messages, we come back, and we get a body tag back. So that's the things we're sending over. And the headers that we get on the server side of things are also a little bit different, so you can notice the colon path and colon scheme and colon authority that come through. It's just a little bit different than HTTP1, but kind of sort of the same. All right, what are we at? All right, so then I wanted to also show you, so this is looks a little bit different than the request response we're used to. But the awesome thing is that somebody came up with a compatibility API. So instead of having to go server on stream and server on error, you're actually also able to do the request response thing. So I kind of wanted to show you that as well. And if you're wondering why I'm looking at my phone, it's because I have a cheat sheet. All right. Another thing that you can, I'm just going to get rid of all of these. So another thing you can also pass in along with the key and the cert is another parameter that's called allow HTTP1. And that's a good one because at that point you can also have clients that are only HTTP1 compatible. So only the latest browsers will accept HTTP2, but kind of the lower versions won't. So you kind of want to be able to say one or the other. We should probably spell it out properly. And then And then you just do the request response thing you would normally do. And you can also do the usual request.end and send the same body tag over. As a response.end. So it's the same kind of situation, which is really nice. Oh, it's response.end, not request.end. And same server.listen and 8001. Right, so looks pretty much exactly as you would write it previously. But let's do a thing where we just kind of compare what we get back. We're going to start and save it again to our keychain because it's a secure server. If I remember my password correctly. Awesome. And then we can curl and get the same body tag back and get the same status code back. So kind of two ways of doing it. All right. The issues with presenting on Google Docs is that they need consistent internet connection. Okay, amazing. So we built a bit of a server. I wanted to mention the package I was using for connecting. It was Tls Keygen. You should check it out. It's really useful for local development. That's not it. I have more to say. All right. So we kind of mentioned the fact that you're sending over settings frames after you've done it with ALPM negotiations. But what are frames? Just a little bit to glimpse over what they are. So frames are used to communicate between the server and the client. It all happens under the hood, so when you're actually developing your applications, you're not particularly using them. But they get kind of sent over, and there's different types. So data gets sent over with data, and there's headers, and there's window update when you're dealing with flow control stuff. Kind of, it just happens as you go. But the interesting things that happens with frames is that you get header frames, and the header frames are the nice ones, and that's kind of one of the efficient things with the HTTP2 protocol. So we'll talk about those header blocks at the moment. So I mentioned before that one of the little wins is the ability to be able to, or the fact that HTTP2 compresses these. So we'll talk about how the compression happens a little bit, which is a flashback to my last year's talk. So the thing is with headers, especially when we're developing our applications, we kind of have the, the usual status and authority and kind of all those headers, but when we're developing, we kind of tend to add a lot of our own. And so that tends to add quite a bit of bytes of overhead. And sometimes kilobytes of overhead if we're using cookies and things like that. So what HTTP2 does is compresses these so you kind of send a lot less things over the wire. And the way that happens is that initially when you send these over, they're first meant to come as a list. So just as the way you send them. So you get authority path, whatever else you want. And then they get serialized into this header block thing. And then you work with those, and those get Huffman encoded into an octet block, which is a lot smaller than what you initially send over, which is a list. And that gets sent over with a bunch of different frames. One of them is push promise, and there's also continuity and continuation frame and push promise. So it's kind of interesting. So it's a lot smaller. You get to save a lot of bytes, and sometimes maybe kilobytes, depending on how many cookies you're using, just because the protocol automatically compresses these for you. So as we kind of talked about headers, I also wanted to, we built a server, but we kind of want to build a client to be able to communicate with these. So instead of kind of building a server, let's build a client. And what we want to be able to do is we want to get the data, and we also want to be able to see the headers that the client gets once it communicates. So this one's a little bit more. This one's going to be a little bit more more involved in terms of coding. So That would be nice. Gonna close these up. All right. So what we want to be able to do is we want to be able to connect to an HTTP2 client. So we're going to need and what we want to do is we want to just do an http2.connect, and we're going to call it client. And what connect takes is it takes a URL that we'll need to provide. And it takes a bunch of options that you can take. But what I'll pass in is I'll pass in reject unauthorized, because what that lets us do is do local development a little bit easier. Right. So for URL, what we'll do is we'll just create new URL. No, you're filming me. So it'll just be a local host, and we'll do 8001, and it has to be HTTPS because it's encrypted. And then we'll just do url.origin to be able to get the origin. So we'll just do it properly so we have an actual URL object to deal with. All right. So that should get us a client. Once we get the client, we just want to be able to handle the error. So client on error, and we're going to handle this one in case something comes in. So that's cool. And then what we want to do is we want to create a client session. So what we'll do is we'll call it request, and we'll do client.request, and we'll pass in a few things to that. That'll just be our request headers, and we'll create that object later. And I don't think we need anything else. And then on request, we'll get a response. So we'll have to deal with response, and response sends us back a few things, which primarily are headers. And those are the few things. So we want to see what those look like in comparison to the servers, so we'll log those out as well. We'll also get data. You get a chunk back. And then we just want to kind of get something out so we get it back together. And then at some point this is going to end, and so we just want to be able to destroy whatever we've started with, which will be client.destroy. And in case there is an error, it's a very good event emitter. It's lots of events coming through. And we just want to be able to do that. All right, so the thing we haven't done is before we make a request, we kind of need a few request headers. So we'll start those off here. It's just an object, and what we want is we want a method which we will use as get, and we want to be able to pass in a path, and we'll just do that. And I think we don't need anything else. All right, so we'll need the server we had from before. So I'll just start off the server, which is HTTP2 server example. Nice. This will create a couple of certs. We won't use them in this example, but you can pass in, instead of passing in reject unauthorized, you can pass in this cert instead. And so what we'll do now is we'll start the client. HTTP2 client. I'm bound to make mistakes, so. Cool, we got an error. Amazing. Connection refused. Pending stream is canceled. Okay, I think I fucked up my it's 8002 is the server. So we'll go back to the client, and what we'll do is we'll change this to 2. And just so you can see, the error is actually quite good. So you see, like with the new, the way new errors get put together in Node is actually kind of good. You can right away see what happens, and you can see the cause most of the time, and a lot of the times it's kind of neat. Cool. The headers don't actually come in properly because I am not sending any, which is fine. I'm going to have to use a different file that actually sends the headers because I don't think I saved our previous example. Oh, right. Okay. I like this collective programming with a room of 100 people. And that's the client. Cool. We get headers, which is great, 200, and that should be good. So now we actually just want to see what the data is like. So on end, what I'm going to do is I'm going to log out the end data. And I won't actually forget to log it out this time. So we don't need to restart the server. We can just restart the client, and we get the same body as we've gotten before, which is great. So it's pretty reasonable thing to do to be able to just kind of send back requests and responses. And we kind of built a server and a client today, which is great. So I've actually built a package that does sort of a little bit more complicated thing than this particular example did, which is called HTTP2 requests. So it does the same thing as what we've done, but actually is able to wrap it around for you. So you just do the same thing as a request or XHR for the browser, called HTTP2 request. You should check it out. So we're going to talk a little bit more about streams. So HTTP2 uses streams. We kind of talked about this, but I looked up the definition from an RFC that I read before this talk. It's basically a sequence of frames. So all those frames put together that we've previously mentioned is called a stream. And a stream kind of rotates through different kind of portions as you go. So it goes between closed to idle to reserved to open to half closed. And you're kind of able to rotate between those as data passes through. And like we said before, multiple of them exist per single connection, so you kind of win out with that. And once you get them at your endpoint, you can combine them from different streams. But the interesting thing that I want to talk about is stream prioritization that allows you to be able to say which streams you want to process as a person or as a computer receiving these. And that kind of comes into the whole thing why HTTP2 is fast and is a lot more performant. So an endpoint, either one of the endpoints, can assign a weight to the stream dependencies. And using those weights, they can prioritize which ones comes first. So essentially what you're looking at is you have a specific stream, and those streams can depend on other streams, and they can have weights. So a stream with a weight of 6 will come through faster and will be processed faster than the stream with a weight of 12. So especially if you're dealing with like a connection that at some point you just want to be able to get something over faster, rather than kind of that write that takes a little bit longer, you can prioritize it with a specific option and get it over faster, which is nice. But the other thing that makes HTTP2 so much faster is the ability to work with flow control, and I'll talk about that briefly as well. So again, we kind of start off single TCP connection, multiple streams, but the fact that you're working with a lot of these streams, you can cause quite a bit of congestion in the TCP because you're multiplexing them. But what flow control does is, as a receiver, you're able to communicate how much you can handle in terms of data frames and header frames. And it only works when you're dealing with data and header frames because those are the ones that are actually the congestion causing types. So once you communicate the data in the header, the receiver will send that its window update or the amount of data it's currently processing as a decreasing number. So the more you process, the less space you have. So it works a little bit like a credit-based system. So you start off with, like, for example, 100, and then you kind of, as more data gets processed, you go down, and eventually you'll have to kind of restart the TCP connection. But what flow control helps is not being able to block. So you're able to kind of figure out how much you can handle at the same time. I also wanted to briefly talk about the kind of how the connection happens in HTTP2 in Node specifically. So what you start off with is you come in with incoming secure connection. What libev will do is it'll do its normal I/O of whatever comes in. What libSSL will do is it'll decrypt the connection, and then you'll get an open stream and an open session from that. And once you get that, you can kind of start receiving frames on the receiver end. And once those frames come in, ng HTTP2, which is a package that parses those frames, parses the request into frames. So that's when kind of the whole frame magic happens. And once the frames get parsed, they get sent over as events and raw data over to your node process. And then your node process can do whatever it does with the request response or stream on response and things like that. And then it sends it over to the initial application. OK, cool. And the last thing I wanted to talk about is server push. So on my little list of little wins, server push allows you to very easily to be able to do one thing. And we'll talk about it in a bit. So what happens in a regular connection is that kind of communication happens, and a client sends over that it wants a specific HTML page. You send over that HTML page. But then once you process that HTML page, the client will want style sheets, and it'll probably want the JS bundle and has to make individual requests for those. And that's not counting kind of the JPEGs and the PNGs and all the images that it wants, because all of those are individual requests. But what happens with server push is a little bit different. So we can kind of see, like, this is a github.com page, and all of these things get sent over individually and get requested individually because they're still using HTTP1. But what with server push you can do is you can preemptively send those things and put them into client's cache. So instead of sending the client having to request those, what you do is you just send them after the client request profile.html, for example. And so once the client needs them, it already has them in the cache and doesn't have to make an entire round trip for it. So I kind of wanted to also do an example of this, because I think this one's really easy. And it's also incredibly effective. You'll see how easy it is. So I'm going to close these up and server push. I'm going to copy over some of these things. So we're going to use Tls Keygen again to do the secure connection, and actually borrow a few other things because we're running out of time a little bit, and I do want to show you this. So you will still create the HTTP secure server. I'm just going to use the Compatibility API. So I get my request and response back. And then what I'm able to do is response has a stream on top of it, and then what you're able to do is send a push stream with the things that the client will be requesting in the future. So this thing that they're going to be requesting in the future is bundle.css, which is cool. So what we then do is then we're able to respond with push streams with a status, and then we send over what it is that we need, which in case is my little bundle.css that's completely not bundled. Which is just sending over a background color, and you can imagine that this can be like a legit bundle that you're sending over, and a legit JS bundle you're sending over. So response.end just sends over a little document. We get a style sheet that wants the bundle.css, and it's got the entire body that I've used previously. Unfortunately, it says Berlin.js. All right. Really? Oh, that's not a session. Is it not a session? Okay. All right. So we're just going to start off the server node server push.js and go through the whole ordeal again. Right. I'm going to use Chrome for this. I was using Firefox before this, but I will use Chrome. And it's on 2000. All right, so we get the background color pink, and that's not the magic yet, and you get the text that I sent over. But what I wanted to show you was actually the network tab. So I'm going to just restart that again. So you see the localhost call. It's a document. Sent over, but it's just a document. But what bundled CSS has done is instead of having it be an entire request, it was just pushed over along with the localhost HTML response.end file. And you can see that from here. So in essence, you're sending the same amount of stuff over the wire, except the user doesn't have to wait for the client to make the request to the server for it, which is a nice thing. And it was literally 6 lines of code to be able to do that with just response.stream, push stream, and push stream.respond with that. Cool. All right. So kind of to finish up with this, the TLDR that I wanted to give you was, again, we work with HTTP2. It's a single TCP connection and multiple streams. I've made sure that I reiterated it a couple of times. Part of the optimization that HTTP2 provides is the fact that it compresses the headers into octet blocks, so you send less things over the wire. Flow control makes sure that you don't have the congestion caused by multiplexing of streams and you don't block. And with push, you're able to preemptively send a bunch of stuff over to the client without the client having to request for it. And you can work with compound mode and still work with request and response and being able to send the same things over with just the same kind of size of things. It's still under experimental tag, but I hear that they're working really hard to make it not be under experimental tag. But it's great. Thanks so much for listening.